Oh, hey, I didn't see you there. It's Alex again. How's it going, guys? Here doing another cut test. I think I'm going to change things up a bit, though. Been doing cardboard, and it's not very economical, in my opinion. So, I'm going to switch to manila hemp rope, and I'm going to get it on Amazon, I think, from this one company. I forget the name, but it is more economical in my opinion, and it's going to kind of get through the test a little bit quicker than what I want to, because like I don't want to spend hours like doing these tests. I want to get it done. So all of my tests going forward are going to be with manila rope, not sisal rope. There's a difference. Manila hemp rope, and all of those numbers are going to be based off of that. And I guess we can do cuts. It's going to be a 1/2 inch rope, so we can do a little math with that as well if we want. So, yeah, I mean, I just think it's a better test and more economical in that sense. Tonight we're going to be testing Native 5 in M4. I sharpen this coarse, fine, 10 passes per side on 1 micron strop. We're going to test this edge. I don't think I'm going to do fine edge because it's like I'm running out of hair in my arm and it's kind of a pain in the ass. So I think we're just going to go until the edge is done, and that should be that. I mean, it's pretty much the same test as what Cedric and Ada are doing on his channel, but I mean, I think I'm using thicker rope, so the test is going to be a little bit shorter. I also have like a nice setup as far as my cutting surface. I'll show you that in a second. Basically, what I did is I took like a thick piece of maple that they had in a factory. It's pretty sturdy, and I glued a piece of like exercise mat on top of it, and then on top of that is a piece of rubber. So it's just going to give me a nice firm cutting surface, but it's going to give a little bit so we're not damaging the edge. So that's one variable that's going to be different in my test, and this, again, the size of the rope. So I'll show you my setup, and then we'll get into the test really quick, and then we'll have a little discussion about what happens with a regrind, like more in depth. And I want to talk about some, studies that have been done on edge geometry and stuff like that. So, yeah, we'll cut to, and we'll get started. So yeah, here's the setup. Here's the piece of wood, the mat, and then we have the piece of rubber. There's already holes drilled in this from whatever they mounted it to. I think it was like a bumper for a tow motor. I put 2 dowels in here. I have my secondary camera here, but the rope is coming through. It's off of the ground. I want to keep it off the ground, so I have a lot of like metal filings in here. They'll get caught up in the rope and kind of give me different results. So basically what's going to happen, I'm going to cut, and the rope is going to be fed through here, kind of just running across here, kind of knock off some debris. That was the idea anyway. I might have a more robust option in the future, but that's what we're going to do. I'm kind of going to cut it here. We're going to mark off a 1 inch section. I wanted it this up higher so I can do the cutting here and not so much like push down this way. Either way, it doesn't matter, I guess, because I'm going to be doing a slicing motion rather than just a push cutting motion. And again, the reason why I did this is because it's a little bit different test than what's been going. The cardboard cutting is cool, but again, it's not economical. And I have a fuck ton of cardboard back here that I need to get rid of somehow. It's winter time and I can't burn anything in my backyard, so yeah, I gotta throw it away. At least with this, I can it can be ground up or whatever, put it in a bucket, and then I can just throw it out back, and it will decompose. So that's where we're at that, and I'm going to tape this up, and then we'll get the test going. Again, I think it's going to be a shorter test than the cardboard, and I haven't looked at the numbers yet as far as the sisal rope cutting test, but this test is also another test that shit, I can't remember his last name. Phil. Yes. He makes fucking awesome knives out of 10V. He's an older dude, makes fillet knives. I'll have it somewhere down here. Phil Wilson. He uses like an inch manila rope, and that's supposed to mimic like hair on an animal or something like that, because he makes fillet knives. Anyway, I also want to do with this type of test is because as far as edge retention, like I don't know if we have any dock workers that are watching, but not often you're going to be cutting manila rope, and manila rope's pretty tough shit. So I mean, mostly we cut like, you know, vegetables, meat, letters, cardboard, stuff like that. So I mean, if this edge can like withstand a lot of abuse from this type of material, then I think you're in pretty good shape. And I know for a fact that there's going to be a difference in edge retention after we do a regrind. And again, I'll explain that all after the test. So we're going to get into it. I'm going to turn on this other camera. We'll have this camera going, and we'll get into it. All right, change of plans. We're going to do it in the front because that's a pain in the ass. All right, that's one. Hey guys, so that test is quick. Learned a few things. So first off, cutting on that squishy rubber, not ideal. Did not know that. Now I know. Second thing, manila rope is a pain in the ass to cut through. I don't care how sharp your knife is, like it's a pain in the ass. I did a little research. Manila rope is actually 20% stronger than sisal rope, so I might buy some sisal rope and try that. Not after the regrind, because we need to keep things the same, and I need to figure out if we got an increase or a decrease. So I think any further testing, I'm definitely going to A, not cut on rubber, B, use a smaller diameter sisal rope, and see where we're at with that. If that still isn't working out, then we'll just change rope. Again, cardboard's just, it's $2 a box, but like, fuck, it's like so stupid. I got so much cardboard over there. I wish you could see it. So there's a bunch of manila rope in this bucket. I don't know if you can see it, but it's a lot, I guess. Yeah, so we can do like math and stuff. Let's see, 0.50 times 60, so it equals 80, divided by 12 equals, so it's like 6.6 feet of manila rope it can cut through, which, is that good? I don't fucking know. This is the first test I've ever done of this, so maybe it's not the best gauge. I don't know, but we'll move on to other stuff. Again, I'm not going to use cardboard anymore. I'm pretty much done with that. Tests take too long, and I got shit to do. So, yeah, this is what this knife. This knife can still kind of cleanly cut paper. The only reason why I stopped was because it snagged like that. It got a little snag. So if I force it through, it'll go through. Barely get some curves on there. So yeah, that manila rope did a number on this thing. But what I really want to get into is what happens during a regrind. So put all this shit aside. So basically, and I'm gonna try to put all this stuff up here too. I'm gonna cut between, but so basically what we have is we have our primary grind, and then the shiny grind. So this is diamond like coating on it. The shiny part is our secondary grind. Excuse me. The primary is typically ground, I think I grind mine at like around 5 degrees, maybe 4 degrees. I can't remember. It doesn't really matter for this sake, but like, let's say it's 5 degrees primary, and then you have your angle is more obtuse. So I did this little drawing, and you can see that we have our primary bevel, or our primary edge, our secondary edge. This whole thing is our blade geometry. This right here is our edge geometry, okay? So 20 degrees per side, 40 degrees inclusive. Here's our hip that I was talking about. I just extended these lines down so you can see the hip a little bit better. And then you have your primary. This is a factory edge. No bueno. This is what happens with a regrind. And I know I kind of explained it a little bit in the first regrind video, but I kind of got annoyed at a video that I saw, and I'm going to explain it, trust me. So, the black is our what we started with. That green swiggly is the stock removal that we removed. And then the red line is our new primary. It's the same angle, okay? The same exact angle. We just took that stock and we shrunk it down. So because this isn't a true, like, it's not an actual angle in the traditional sense. So when you have an angle, it's just boom, boom. That's your angle. But because we just added this other part, and we have our hip here and here, it's different. So if I maintain that same 5 degrees and I remove stock, I'm now changing my hip from up here to down here, and thus I'm not changing the secondary, but I am removing enough stock to where it is now easier for me to obtain a 15 degree per side or acute angle on this. The thinner I go, the more acute angle I'm going to get eventually, because eventually if my stock removal is all the way out here and I get down to that point, there's going to be hardly any angle on it, and then I can just grind it straight flat. And now then at that point my entire knife would be a 5 degree knife. It'd be fucking super sharp and it'd cut through fucking everything. So to say that a regrind does not help edge retention, yes and no. And again, it is a small number, but a regrind does help edge retention. But more importantly, it helps with how the knife performs and how the end user feels. It's going to slice through things a lot easier. It's going to feel a lot more slicier. You're going to have less material that you're abrading through, because let's face it, if we have a thicker stock, then we're abrading through we're using more material to abrade through material. And if I took this knife, which isn't even ground to anything, and fucking try to cut something, I'm not going to be able to do it because the edge is like 180 degrees. So it's flat. Or 90 degrees, or whatever you want to call it. 90. So basically, a regrind does help in the sense that you're taking material off, you're thinning your stock, and then you are ultimately thinning your edge geometry, which is different from our blade geometry or edge geometry. And it's giving you 15 degrees per side. And this is obviously after you sharpen, but it's going to be easier to obtain a 15 degree per side. Also, it's going to be even more sharp if you put a convex edge on it, because now you're just taking that hip and you're just curving that hip, and it's turning into a better performing knife. So really quick, I don't know if you guys go on, Knife Steel Nerds or anything like that, but there is a little, well, first let's start out with, if you don't go on knifesteelnerds.com, go there now, check it out. That dude fucking puts out great articles, and they're super informative. And if you don't want to learn about it, whatever, but like learn about it for like just being in the community, if you're in the knife community, even if you want to get into knife making, like it's actually helped me become a better knife maker. I pay attention to more things that I wouldn't have paid attention to before. So go check them out. Secondly, you need to check out Roman Landis. He is a German knife maker / I don't know if he's a metallurgist, but he is a sciencey guy. And he wrote this book that you can only get in German, and I want to get it. So I'm going to try to hit him up and see if he has a PDF, so then I can translate it on my own, and I'm not going to give it away to anyone because that would be fucking stealing. Anyway, if you go to the article Edge Stability on Knife Steel Nerds, you'll see this little printout like this. It's obviously longer. I have it folded because you're supposed to fold it. And this is basically explaining this is getting into more of your edge geometry, but it's talking about how steel affects stability, so you can create a thinner edge geometry. So you have all these steels down here, and these are obviously, they're magnified. You have D201, Talonite, CPM S90V, 440C. So all these white parts in here are carbides. You can see D2 has like weird carbides, Talonite has weird carbides, and 440C has weird carbides. O1 tool steel is kind of like small carbides, and then because it has very little vanadium in it, if any. And then you have CPM S90V, has decent sized carbides, but the grain structure looks like it's like a bunch of like Dippin' Dots or whatever. And that is the main point of the guy's book, is all of this stuff wrapped into how an edge is stable with certain steels, the way you heat treat, the way people use their knives, things of that nature. There is some like free like pages you can go read or whatever, and it basically talks about all this stuff, and it comes down to like the reason why companies like have such thick edge geometries is because people that use knives are fucking stupid. Like, they're idiots. People that know how to use knives aren't, but pretty much most of the population are fucking morons. And they're gonna go in and they're gonna like fucking stab shit and twist shit and twerk shit and fucking, you know? That's not what a knife's for. It's for fucking just cutting things. And then you can use other tools for other things. And then getting into that, like, a thinner edge geometry is going to cut better because basically, well, from what I got from it is you can get a thinner edge because you have higher quality steel. The higher the quality steel, the thinner the edge you can get. Probably not true. I know there's some steels out there that are pretty, like, Sandvik steels are pretty decent, and they're not like crazy super steels, but you can get a very, very thin edge. But again, that comes down to grain structure. So it's all a bunch of shit that comes together, and it's what science is able to prove right now. So I mean, if anyone else can like prove otherwise, like, go for it. If you can't, then don't. But definitely thinner edge geometry is going to help you or help your knife perform a lot better, and you're going to notice it. It is also going to indirectly help with, directly, edge geometry is directly going to help with wear resistance. Again, so anyway, this thing's on there, and you can print it out, and then you fold it up, and you kind of fold it so it looks like a little knife blade. And I'm going to edit this part out, but alright, so I'm back. So basically you fold it so it looks like a knife. As you can see, you put these paper clips on top, and then each one of these parts right here, if you look through the light, you can see the back of that paper that's been folded, and you can adjust the angle. So yeah, let me just lock this really quick. All right, so we have angle of the edge for a full triangle in degrees. So we're at 15 currently. That's obviously a fine edge. So this is for a full triangle. So if this edge were, if this edge right here were 15 degrees inclusive. And then it goes up from there. 15 and 20 are fine edges. So at 20, we're at 10 degrees per side. 30, which is, pretty standard, we're at 15 degrees per side. Or 20, we're at 10, 30, we're at 15. And it goes up from there. And a lot of factories actually ship their shit out at 40. and that's in the red, no bueno. And then if we come over here, you want to be very accurate, obviously in folding. So, what does this say? Cutting quality and performance. So, we have a 15 degree, which is that red line. Fucking, yeah. Amazing cutting quality and performance. So, performance meaning performance of the knife, how easily it can go through, and edge retention. Again, if we go up, we're at 30. Go across, not ideal, but we're still in the green here. It's pretty good. So, the point being, check this out. Look up Roman Landis. Again, I might have links in the YouTube so you can go, hunt shit down. If anyone speaks German, fucking help me translate the book, because I'm gonna buy it. But I want to try to buy a PDF because there is a translate function in Google. So you can translate it in English, and it works fairly well. I've used it on other things. So, and then, yeah, again, he talks about carbides and, grain structure and how that also helps all of this. So basically, there's like 5 takeaways from that. It's just like your steel, your grain structure, your heat treat, your edge angle, and just the way you use your knife. But yeah, I just wanted to touch on that. Like, doesn't directly affect edge retention, but it helps. And in my opinion, it helps more than people think. I've done like 6 regrinds, and I think I've tested like 3 or 4 of them, and I've had increased performance, whether it be 20% or 24% performance on edge retention. So I'm sure if I tweak my angle to 15 degrees, I usually do about a 17 degree per side angle, I would have better results with a 15, but that's just what I do. I do me. Also, you do you. Like, you don't have to fucking have a thin ass fucking knife. It'll help. But also, you don't have to have a thin, like, secondary edge. Just do whatever you want, man. Live your life. Got one life, so fucking live it. You want to do a regrind. If you don't, whatever. I regrind pretty much all of my knives. I just like the performance it gives me. And it's way easier to sharpen too, because you're not fucking abrading through all that material. But yeah, that's gonna be the wrap up here. Again, I'm gonna regrind this knife probably down to 15 to 13 thou, and then we're gonna redo that test again. I'm gonna use the same rope, same method, and see if we get a little bit of increase. If we don't, we don't. I can't do the test again after the fucking regrind's done, so it doesn't really matter. I might end up, maybe switching gears for a little bit. I haven't really been able to hunt down any customs, so I'm gonna try to reach out to people. I'm very lazy about that. But yeah, I think the next video I put out is gonna be me grinding this knife and then doing a test, and then after that we're gonna talk about probably one of the best cutlery companies that ever existed. Not Spyderco, a different company that you've probably never heard of. And I'm really excited for that video, and I'll explain why in the video. So yeah, we'll talk about that. Those are going to be the next few videos coming out. So yeah, again, if you have any questions about regrinds, let me know. If you know any custom makers, let me know. I would like to get a hold of some steels. Again, like A2, O1, any of those things. Anything we can like find an equivalent in a production knife width. So yeah, let me know. And yeah, thanks guys.